So the surface area of a sphere is 4 pi times the radius of the sphere squared. And if you're like me, you're wondering how in the world does someone come up with this? And is there any tangible way to visualize it? And the answer is yes. So if you take this sphere and you project the face of the sphere, what you will find out is that you can project it and manipulate that projection to look exactly like the surface of a cylinder down here. And I went ahead and I drew this cylinder, but just so that we're on the same page, what I mean is this. If I come around the middle of the sphere and make a circle around the sphere like it's a cross section, and then I project it outwards, I would find that it would project outwards on the cylinder something like this. And that middle line that's black on the sphere, to give it a three-dimensional look, would also project about smack dab in the middle of the cylinder. And if I took a green line and I wrapped it around the top tighter than the way I wrapped it around the bottom, when I project it outwards, even though it is smaller here, it's going to get stretched out a little bit. And when it wraps around the edge of the cylinder, I should expect it to place this green line about here. So if I project it outwards, it's giving me this kind of a picture. And just to maybe give you one more quick picture, if I went over here and I made a dot on this green line, a dot on this red line, and I connect them, on a sphere it would maybe look rounded from this point of view, but when I project it out on the cylinder, it would appear to be very straight because of the shape that it would take on when I project it outwards. And so I hope this helps you visualize what we're doing here. We're projecting this sphere outwards into the shape of a cylinder. And so when I project this, I come to this realization that the surface area of the sphere is going to be equal to the surface area of the lateral face of the cylinder. But the area of the cylinder's outside is going to be hard to calculate as is. So what we're going to do is we're going to kind of unroll the cylinder. So if you take one edge of the cylinder, if you think of this as like the label of a soup can, and you peel it off the soup can, what you'll realize is the label of the soup can unrolls into the shape of a rectangle, just like this. And so we realize that right away the height of this rectangle is going to be whatever the height of my cylinder is. But what is this distance going to be right here? And we realize that if I do this in purple, the distance from edge to edge, the width of this rectangle, is going to be exactly how far around this circle it travels. And so one distance around this perimeter of the circle, that's going to be the circumference of the circle. And if you remember how to find the circumference, it's 2 times pi times the radius. And so what we realize is the width of this rectangle, the width of the label of the soup can, is going to be 2 times pi times radius. And so now to find the area of this lateral surface of the cylinder, we need to find out how tall this is. This is where it helps to think about the sphere and the cylinder. The cylinder is exactly 1 radius wide. It's going to be the same width as the sphere. But when I project it outwards, what happens is it also has the same height. Well, if we think about what the height of this sphere is, the height of the sphere, half of it is going to be 1 radius, right? The center of the sphere, from the center to the edge is always the radius. So that means half of the height of this sphere is going to be 1 radius, which means the bottom half is also going to be 1 radius, meaning the height of our sphere is going to be exactly 2 radii. So when I project it outwards into a cylinder, the height of my cylinder is also going to be exactly 2 radii, which means the height of my label is also going to be exactly 2 radii. So if I remember how to find the area of a rectangle, area is always equal to length times width. And in this picture, my length is 2r. So I'll put 2r times my width, which is the circumference of my cylinder, which is always 2 pi times the radius. And so now when I multiply this and combine like terms, 2 times 2 gets me 4. Pi just stays as pi. And radius times radius gets me radius squared. So when I think about it this way, I come to a grand conclusion that the surface area of a sphere is equal to the surface area of the lateral surface of a cylinder. And I just discovered the lateral surface of a cylinder, when it is projected from a sphere, is exactly 4 pi r squared. So that means this is where the surface area of my sphere comes from.